Let's start with circle. A circle is the set of all points in a plane equidistant from a fixed point that we call center. So this is what a circle looks like. It's the set of all points in a plane equidistant, meaning it has equal distance from a fixed point that is the center. So this is equal from here up to here, from here up to here, up to here, here, here. This is equal. The distance from the center to any point in the circle is what we call the radius. So from here up to here is what we call our radius. A circle with center at the origin has the standard form of equation x squared plus y squared equals r squared. Okay, let's derive the equation of the circle. In deriving the equation of the circle, remember the Pythagorean theorem, the right triangle. If you have a right triangle, you have two legs that are equal and a side that is the longest side. So if you want to get the length of this side of what we call the hypotenuse, the square of the length of the hypotenuse is just equal to the sum of the squares of the two legs. So c squared here is just equal to a squared plus b squared. Okay, so we recall the distance formula in finding the length here. Okay, if you have 2 points O and P and you have this length as your distance, how do you solve for the distance formula? You follow the Pythagorean theorem. If you have this right triangle, you have 2 points O and P. You have this side of the hypotenuse as your distance, and of course the two legs, we'll label them as A and B. Okay, the length of A is from x sub 1 to x sub 2. The length of B is from y sub 1 to y sub 2. Recall the Pythagorean theorem, c squared is equal to a squared plus b squared. In this case, for distance formula, our c is now distance, or we just denote that as d. So d squared is equal to the sum of the squares of the two legs is equal to a squared plus b squared. How do we get the distance of A? The distance of A is just the difference of x sub 2 and x sub 1, right? The distance of our A is just the difference of our x sub 2 and x sub 1. And the distance of our B is just the difference of y sub 2 and y sub 1. That's why we put that here. D squared is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And get the square root of that. We have our distance formula equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So in this case, our distance is now labeled as r, or the radius at the circle. So we have points C and point P. Point C is the center of the circle, and point P is any point along the circle. So this becomes our radius now. This one, the hypotenuse is the radius. So from the distance formula, which is d squared is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. We replace d with r now. So we have r squared is equal to our x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. In here, our x sub 2 is what? Our x sub 2 is the point x. Is the x in our point in the circle. So x sub 2 is just x. Our x sub 1 is in the center. So x sub 1 here at the origin is 0. Our y sub 2 is the y in the point, so that's y. And our y sub 1 is the y in our center, which is 0. So our r squared now is equal to x minus 0 quantity squared plus y minus 0 quantity squared. And there we get the equation of the circle whose center is at the origin. R squared is equal to x squared plus y squared. If the center is not at the origin, then you have a center of hk. The equation now becomes x minus h squared quantity squared plus y minus k quantity squared is equal to r squared. So the center now is not along the origin. It's no longer 0, 0. Okay, the general form of equation of the circle is ax squared plus by squared plus cx plus dy plus e equals 0. So let's derive that. If the center of the circle is at the origin, we have this formula. R squared is equal to x squared plus y squared. But if the center is no longer at the origin, so we have this, we have center, the coordinates of the center as hk, and we also have our point that lies along the circle xy. Okay, so our r squared is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Our x sub 2 here is our point along the circle, that's x, and our x sub 1 is the x coordinate of our center, which is h. Y sub 2 is the y coordinate of our point P, that's y. Our y sub 1 is the y coordinate of our center, which is k. Okay, so r squared becomes our x sub 2 is x minus our x sub 1 is h squared quantity squared plus y minus our y sub 1 is k quantity squared. So this is now the equation of the circle whose center lies not along the origin. Now we will derive the general form of equation of the circle. We know already that if the circle's center does not lie along the origin, The formula is r squared is equal to x minus h quantity squared plus y minus k quantity squared. According to the symmetric property of equality, we can just write this as x minus h squared quantity squared plus y minus k quantity squared equals r squared. Now, if we expand the equation of the circle, let's recall the perfect square binomial. If you have a plus b quantity squared, expanding this, you just square the first term, and then you add exponent 2 multiplied by the first term and the second term, and then you add the square of the last term. So this becomes a squared, square of the first term, plus twice the product of the first term and the second term. So 2ab plus the square of the last term b. Okay, so you have a squared plus 2ab plus b squared. If you have this form of binomial, a plus b quantity squared. Now if you have a minus b quantity squared, to expand this, again you square the first term, so that's a squared. This time you multiply the first term and the second term, and then multiply that by 2, so plus positive 2 times a times negative b, and then you add the square of the second term, so that's negative b squared, and then you get a squared minus, because this is 2 times a times negative b, then the product is now negative 2ab. The square of a negative number is just a positive number, so that becomes plus b squared. Okay. So we will be using this one. Remember that if you have a minus b squared, to expand that, you just write square of the first term, a squared, minus twice the product of your first term and second term, so 2ab plus your second square of your second term, b squared. Okay, in this case, we have x squared minus 2 times x h plus h squared plus y squared minus 2yk plus k squared equals r squared. I hope you got that. So let's combine x squared and y squared, and the second terms minus 2xh minus 2yk, and then the last terms plus h squared plus k squared is equal to r squared. Now the coefficients for x squared and y squared are 1, so we can just denote them as a and b respectively. Also, we denote negative 2h and negative 2k as c and d. So this one, negative 2h and negative 2k as c and d, because these are just constants. We have x and y as our variables. So we write this becomes ax squared plus by squared plus cx plus dy plus h squared plus k squared. We transpose this r, so this becomes minus r squared equals 0. And then we denote the constants h squared, k squared, and r squared as e. Okay, so these are constants So we denote them as E. So the final general form of equation is now ax squared plus by squared plus cx plus dy plus e equals 0. Okay, that's it for today. If you have parts of the video that you found it too fast or hard to understand, kindly pause and then replay, and then pause again, replay, and try as much as you can to understand everything.